The net force simulation is an engaging educational tool designed to help students understand the principles of balanced and unbalanced forces through a dynamic and interactive context. In this simulation, students investigate the difference between balanced and unbalanced forces as pullers compete in a tug of war for a cart of candy. By manipulating the number of pullers and observing the resulting motion of the cart, students gain a practical understanding of Newton's laws of motion. The net force simulation is based on Newton's first and second laws of motion. Newton's first law states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The simulation provides a visual representation of these laws, allowing students to observe how changes in the number of pullers affect the motion of the cart. Key components of the simulation. Cart. The cart represents the object whose motion is being studied. The cart can be at rest or in motion, depending on the forces acting on it. Pullers. The pullers represent the external forces acting on the cart. Students can add or remove pullers on either side of the cart to create balanced or unbalanced forces. Frictionless environment. The simulation operates in a frictionless environment, allowing students to focus solely on the effects of the applied forces without the complicating factor of friction. Motion indicator. The simulation includes a motion indicator that visually represents the acceleration and direction of the cart's motion. This indicator helps students understand the relationship between net force and acceleration. Exploring balanced and unbalanced forces. The net force simulation provides a hands-on approach to exploring the principles of balanced and unbalanced forces. By adjusting the number of pullers, students can observe the following key concepts. Balanced forces. When the number of pullers on each side of the cart is equal, the forces are balanced. In this case, the net force acting on the cart is zero, and the cart remains at rest or continues to move at a constant velocity if it was already in motion. This demonstrates Newton's first law, as the cart's state of motion does not change unless acted upon by an unbalanced force. Unbalanced forces. When the number of pullers on one side of the cart is greater than on the other side, the forces are unbalanced. In this case, there is a net force acting on the cart, causing it to accelerate in the direction of the greater force. This demonstrates Newton's second law, as the acceleration of the cart is directly proportional to the net force acting on it. Effect of adding pullers. If more pullers are added after the cart is already in motion, students may observe that the cart continues to move even if the forces become balanced again. This is a great teaching moment to reinforce the concept that an object in motion stays in motion unless acted upon by an external force. Students can run tests to understand that the motion was already happening and that the addition of balanced forces does not immediately stop the cart. Mass and motion. In the frictionless environment of the simulation, adding mass to the cart does not change its motion. This can be a challenging concept for students to understand, as they may expect the cart to move more slowly with increased mass. However, in the absence of friction, the cart's acceleration is solely determined by the net force acting on it, regardless of its mass. This provides an opportunity to discuss the role of mass in Newton's second law and the importance of considering all forces acting on an object. The net force simulation offers several educational benefits. 1. Interactive learning. The simulation provides an interactive and engaging way to learn about balanced and unbalanced forces. Students can actively participate in the learning process by adjusting the number of pullers and observing the effects on the cart's motion. 2. Visualization of abstract concepts. The concepts of balanced and unbalanced forces can be abstract and difficult to understand. The simulation provides a visual and tangible representation of these concepts, making them more accessible and understandable. 3. Experimentation and exploration. Students can experiment with different numbers of pullers and observe the resulting changes in the cart's motion. This exploratory approach encourages critical thinking and problem-solving skills. 4. Real-world application. The simulation provides a practical application of Newton's laws of motion, which are fundamental principles that govern the motion of objects in the real world. This helps students see the relevance of these concepts in everyday life. 5. Data collection and analysis. The simulation introduces students to the process of data collection and analysis. By observing the motion indicator and recording the changes in the cart's motion, students can collect data and analyze the relationship between net force, mass, and acceleration. The net force simulation is a valuable educational tool that brings the principles of balanced and unbalanced forces to life through an interactive and engaging context. By allowing students to manipulate the number of pullers and observe the resulting motion of the cart, the simulation provides a hands-on learning experience that enhances understanding of Newton's laws of motion. This interactive approach not only makes learning more enjoyable, but also fosters critical thinking, problem-solving skills, and a deeper appreciation for the relevance of these fundamental concepts in the real world.